morning, everyone. It is 11:02 and we are going to get started since we have a quick 45-minute session for you. My name is Kelly Trott. I'm the VP of Deployment and Impact at Imagine H2O. We are excited for our second session at Stockholm World Water Week. Thank you so much for joining the Swedish Fish Tank, a Shark Tank inspired startup pitch session on coastal resilience. Again, I want to do a special thank you to our challenge founding partner, 11th Hour Racing. We are very excited to have one of your colleagues on today as a Swedish fish. And as a little bit of an overview today, I'm going to give you a brief background about Imagine H2O and the challenge. I will then be joined by Michelle Carnevale with 11th Hour Racing and Allegra Gordon of Oceankind to discuss the coastal resilience spotlight of the challenge. They will then put their mean Swedish fish faces on as they share, as three of our 2020 Urban Water Challenge finalists will present how their innovations play a role in achieving coastal resilience. This will end with an interactive voting from you on which entrepreneur came out of the Swedish fish tank alive. So for those of you that don't know, Imagine H2O is a 501c3 nonprofit with a mission to empower people to develop and deploy innovation to solve water challenges globally. We do this through three main programs. We run 2 water startup accelerators and customer validation platforms. Both are remote, which is great right now. And one is run out of San Francisco and the other is out of Singapore. And then we run our Urban Water Challenge, which we will be digging into today. So we did a whole session yesterday on the Urban Water Challenge in the background. So if you want to learn more, we will be broadcasting that session out tomorrow. So dig in there. But for a broad overview, we developed the Urban Water Challenge to accelerate the adoption of promising solutions to build resilient cities. We do this by supporting innovations that advance the way we source, clean, distribute, use, treat, and reuse our water. Specifically, the challenge provides pilot funding to jumpstart these deployments and create proof points for end users, with this goal of accelerating the adoption of these emerging solutions. This year, we will be awarding over $275,000 US in deployment funding. But at Imagine H2O, we think that in order to be truly catalytic, you got to go beyond just the funding, which is why we connect entrepreneurs with expert deployment partners and Imagine H2O's global network, giving them the resources they need to flourish. We also work to amplify the success stories of these deployments through storytelling, like today. So, what kind of water solutions do we support? We get this question all the time, and the answer is we support a lot of different types of water solutions. Anything that's, addressing some of the biggest water problems in the world, from combating water contamination with monitoring technologies to reducing pollution through better wastewater treatment. What all of these have in common is that they are advancing the following UN Sustainable Development Goals. This year, we will be spotlighting innovations that have an impact on coastal resilience, i.e. the discussion at hand today. So before digging into it myself, why coastal resilience? I'm excited to bring together our 2 Swedish fish to dive deeper into their coastal resilience discussion before meeting with the entrepreneurs. And these are our 2 Swedish fish. I'm just going to stop sharing for a moment so I meet them in person. First up, I am very excited to introduce you to Michelle Carnevale with 11th Hour Racing. Michelle and 11th Hour Racing have been a thought partner with us for the past 3 years and really have made this challenge a reality. Michelle, thank you so much for coming today. And would you be able to give us a little bit more about your background and what your organization does?
Hi, everyone. Thanks, Kelly. My name is Michelle Carnevale. I'm the Grant Program Director for 11th Hour Racing. 11th Hour Racing is an international organization that funds projects and initiatives that protect and restore the health of our oceans and waterways. Our grant making is supported through the Schmidt Family Foundation, and through our grant program, we help communities implement more sustainable practices and more efficient use of natural resources. So our ultimate goal is really to support local solutions to global problems. And as Kelly mentioned, this is our 3rd year supporting the Urban Water Challenge, in part because we believe so strongly that there's this urgent need for solutions to help communities globally tackle issues of water quality and scarcity. And also just a note to the entrepreneurs that we are friendly, mission-driven sharks.
Thank you, Michelle. I also wanted to welcome our second panelist, Allegra Gordon with Oceankind. Allegra is extremely passionate about the topic of coastal resilience and the connection between ocean health and cities. I think we talked about it the first time we ever met. So with that, Allegra, will you give us a bit of your background and kind of how you're thinking about it at Oceankind?
Hello, my name is Allegra Gordon, and I am a program officer at Oceankind, a grant maker whose mission is to improve the health of global ocean ecosystems while supporting the livelihoods of people who rely on them. Oceankind works to address the 4 major ocean threats, which are climate change, habitat loss, unsustainable fishing, and my program area, coastal pollution. Within the marine pollution context, we're currently focused on sewage pollution, given its global extent and the many harmful effects it has on ocean ecosystems. So in conversations with the water and sanitation sectors, I tend to wear the hat of the oceans. So I'm grateful to be here as a thought partner as we explore the intersections of cities and oceans. Thanks for having me.
Great, thank you so much, Allegra. And I'm just going to dive right in. We're going to be talking through coastal resilience today. And I know this term resilience is being used a lot right now. So I'd be curious, Allegra, what does it mean to you?
Well, Kelly, I'm so glad you asked because I think about this all the time. It's a huge passion of mine. To me, resilience is about the ability of a system to maintain continuity through acute shocks and chronic stresses, which moving towards sustainability. And this is the idea of bouncing back better. Coastal ecosystems are critical to enabling resilience. In the US, for example, 127 million people live on our coastlines, which represents about 40% of our population. And the coastal economy makes up 43% of our GDP. So coastlines are important to our economy and our livelihoods. Coastal ecosystems like seagrasses, salt marshes, estuaries, and coral reefs also play a critical role in protecting our coastal economy. We're seeing much how we need these ecosystems play out right now as cities become more vulnerable to the effects of a changing climate, like sea level rise, more frequent extreme weather, and flooding. In my role at Oceankind, I see pollution as both a chronic stressor and an acute shock to coastal ecosystems and the people who depend on them. From a chronic stressor perspective, more than 50% of our surface waters in this country are degraded, in large part due to centuries of pollution from industry, development, and human activity. For example, let's look at Long Island in New York, which has lost more than 90% of their salt marshes due to the 400,000 septic tanks that chronically leak directly into the marine environment. With ecosystems that are so degraded, it makes it hard for them to fulfill a function that protects homes and businesses from storms and flooding. And then there are acute shocks. Another huge ocean problem is this issue of stormwater overflows. Since many cities have what's called combined sewers, when it rains, runoff mixes with raw sewage and overflows directly into our waterways. Because our water quality monitoring is relatively limited, beachgoers can go to the beach after it rains and get exposed to all kinds of nasty things in sewage, which makes them really sick. So with chronic stresses and acute shocks, to me, coastal resilience looks like protecting and restoring the beaches, estuaries, wetlands, marshes, corals, seagrasses, so they can protect us from flooding and disease.
I totally agree. And I think that recently we all now have a new appreciation for what resilience really means. I mean, if the last 6 months haven't taught us what resilience means, I don't know what will. But it can mean so many different things, like Allegra was saying. But at its core, I think the foundation is really about the capacity of a community to adapt continuously to stress and change over time, both the short term and the long term. And resilient cities need to consider so many different aspects: their energy, their transportation systems, their food systems, their economy. But when it comes to water, as Allegra was saying, I think the most common issues that we hear from local decision makers that they're struggling with flooding from both storms and sea level rise, wastewater management and pollution, access to and more efficient use of clean drinking water. We see this firsthand in communities that we work with from Cape Town, South Africa, throughout the US, This is just whether it's the impacts of climate change or plastic pollution or polluted runoff. We need innovative solutions every day. We need the need is growing every day. So I think highlighting resilience during this edition of the Urban Water Challenge is so critically important because there's just such a growing need around the world, and the status quo is not working for us any longer. We need more innovators developing better ways to conserve and reuse and protect this natural resource and help cities become more water resilient in the face of climate change. So I'm excited to hear what the entrepreneurs are going to pitch.
Yeah, absolutely. And as we kind of dig into this urban water resiliency topic, can you say a bit more about this connection between urban areas and kind of ocean and waterway health? And why do you think most people are only talking about one or the other? It seems like in the water world, it's either you're a drinking water person, you're a wastewater person, you're an ocean person, but why aren't we just like one water person trying to figure it all out together?
Cities today are truly the front lines on the impacts of climate change. Like, some communities are dealing with too much water from sea level rise or storm flooding or increased runoff, whereas other cities are dealing with not enough clean drinking water with the growing demand, or in some cases it's both at the same time. At the infrastructure of our cities, they were not designed to accommodate the amount of demand and rapid change we're seeing with climate change. And we see that on a regular basis in our hometown in Newport, Rhode Island, and throughout the Northeast of the US, like these combined sewer systems like Allegra was talking about that are regularly overflowing into the bay, where it's impacting tourism and the fishing industry. Or we're seeing frequent flooding during high tides or storms, where they're covering streets, washing plastics and contaminants directly into our waterways. And these aging pipes that were put in 30 to 60 years ago that are now failing or in disrepair. But with all those challenges, I think cities offer this amazing opportunity to test new ideas and be these innovation hubs. So I think more and more we're seeing the conversations around how do we design more sustainable, more resilient cities that have fewer environmental impacts. And I think the Urban Water Challenge is such an exciting way to support those new ideas.
Thanks, Michelle. And it's funny, I think we've had this conversation together around like ocean health is not necessarily a term that we've used in the Urban Water Challenge, like upfront, like immediately. So I'd be curious, Allegra, like how does Oceankind think about ocean health and its connection to cities?
That's a really good question. Ocean health sounds like a vague concept, but it's actually rigorously studied and broken down into different goals around food provision, tourism, recreation, livelihoods, economies, and more. And if you want to learn about how this is structured and assessed, go check out the Ocean Health Index online. Great information. I personally see connections between cities and ocean health every day. And the relationship goes both ways, where cities affect ocean health, but also ocean health affects cities, much like Michelle was just saying. Municipal pollution, septic tanks, and urban runoff are the three of the leading sources of pollutants and stressors causing ocean water quality impairment in the US. Ecosystem impacts include destruction of coastal habitats from pollution and fishery closures. So cities affect ocean health. And when the ocean is degraded, it in turn affects the health of the city. Degraded ecosystems poorly protect coastlines from flooding and storms. People get sick from going to the beaches, from consuming contaminated seafood, and from being around these harmful algal blooms. There are GDP implications from beach closures and fishery closures, and unfortunately, sewage pollution really affects people's sense of place, which isn't often discussed. And for example, in Ghana, in the city of Accra, there's a place called Lavender Hill, where they dump all of the fecal sludge that is pumped out of the pits from the city. And this sludge seeps directly into the ocean. So no one goes to the beach anymore. And this is really sad that they've lost this connection to their coastline. So cities affect oceans, oceans affect cities. And unfortunately, these two problems have been tackled in silo rather than being solved holistically.
Yeah, and Allegra, we talk about silos a lot. I know you and me, and it feels like we're constantly also working on solutions in silos. I mean, we talk a lot at Imagine H2O about technology, but can you elaborate a bit more on kind of what are those different levers that can be pulled in terms of solutions around this?
So the great thing about marine pollution is that it's solvable. And we have solutions today that we know can improve coastal water quality and help reconnect people to the coastlines. At Oceankind, we think about solutions in three levers: communications, policy, and technology. So let's quickly dive into each. From a communications perspective, we want to make sure people know that this is a problem and they're motivated to do something about it. Specifically, we need to monitor our coastal water quality to identify these key problem areas. But from a bigger picture, we also need to make sure people in positions of power and influence, like lawmakers, mayors, business owners, foundations, are aware of these largely invisible problems. And so it's great to know about it, but ultimately we have to address the problem. So policy becomes a major lever as we need to define and enforce the rules of the game. There are great laws out there in almost every country about protecting ocean health. The challenge is in the implementation. Legal groups in the US and internationally pursue strategic litigation and ensure that laws are enforced. But in some places, the laws haven't been written in detail. The rules create the markets because no one wants to pay for water quality. So sometimes solutions have to be mandated. And once policy is strengthened and enforced, we need technology to make solutions cheaper, easier, and more effective. You know, people often think, oh, let's just build a wastewater treatment plant. But for much of the world, that's really cost prohibitive. And even in the US and Western Europe, our sewered infrastructure is broken. We need new solutions to make it easier to improve ocean health so that it's not just an added cost, but can be integrated into how we do things.
I would just add, I love those three levers, and I'm going to just add another one. I also wanted to highlight the role of nature-based solutions. And Allegra, you talked about this earlier as well, but that restoring natural systems can help to absorb and filter runoff and buffer storm impacts. Things like green infrastructure and oyster reefs and mangroves and marshes and seagrass, like all of those, that's an important lever that can go hand in hand with innovation and technology. And the fact is we need all of these levers and they all need to be working together. And the one thing that I think that does need to be looked at overarching across all of the levers and solutions is this concept of inclusion and ensuring that all members of the community are considered and incorporated. I think so often poor water quality, pollution impacts, limited access to clean water is felt by the most underserved and vulnerable members of the community. So having that be central in all of the levers that we push, I think is really important.
I agree with you both, Allegra and Michelle. And as part of the Urban Water Challenge Spotlight this year, we're hoping to bring together many stakeholders to have a bigger conversation around how different solutions can work together to help solve these issues. And we're actually partnering with several organizations to share information on our shared seas. And we'll be releasing a post later this month. If you want to learn more about that and join the community, go to www.oceansewage.com. And in just a minute, you two are going to become very intimidating Swedish fish. So before we do, I just wanted to dig into that technology lever a bit more and see, what do you think about, what do you see as the opportunities as well as the barriers for technology in this space? And specifically, maybe Michelle, you can start off.
Yeah, we hear over and over from local decision makers and industry members that often the risk is too high for them to invest in new technologies or deploy new innovations, whether it's too much money, too much investment, too many uncertainties. And that's where I think philanthropy can really play an important role to help accelerate deployment. So 11th Hour Racing, we hope that our grant funding can serve as a catalyst for better and more sustainable ways of doing things in our communities. And I think this challenge is such a perfect opportunity to do that. What I think makes the Urban Water Challenge so unique is its focus on deployment and getting those projects in the ground and having a real world example. These awards provide direct support to these real world pilots and showcase that this technology can work, and it can hopefully unlock even more opportunities for the entrepreneurs and the companies.
Well, Michelle, you just literally took all the words out of my mouth. So great explanation and answer. I agree that we need to help to accelerate deployment. The only thing I'll add is that I think there's a real need to raise the profile of invisible problems that don't often get emphasized. We see nutrient pollution as one of the biggest threats to ocean ecosystems, yet tertiary treatment of sewage in coastal cities is not always prioritized. So I tend to advocate for preventing nutrients from entering waterways upstream, which has its own barriers from technology being too expensive, requires too big of a footprint, and it's not always incentivized through policy. So there's a huge opportunity to drive solutions through innovative technology, which is why I'm thrilled to be in this virtual room with Imagine H2O and its network today.
Great. Thank you so much, Allegra and Michelle. I think this is the perfect transition into the Shark Tank portion of our session, where we will be taking a closer look at startups solving from some of these visible and invisible problems. So I don't know if everyone on the line has seen the show before, but we're going to have 3 startups present to these very 2 Swedish fish, Allegra and Michelle, who have pointed questions around the startup and their connection to coastal resilience. I just want to make sure I can get back up our slides. And these are going to be the 3 different entrepreneurs. First up, we have, all the way from The Hague, we have Karina Peña ready to show the Swedish fish her rainwater harvesting technology. Karina, you can take it away.
Hi, everyone. I am Karina Peña. I am co-founder and CEO of Field Factors. We are a Dutch startup disrupting the urban water system. And we do this by turning rain into a local sustainable source for freshwater supply. Next is too much or too little water, or too dirty, as we have heard. These are big challenges our cities are being confronted with due to climate change. But let's take a look at our cities, or at the way how we have built our cities. Since the 19th century, centralized water supply and drainage networks are part, or have been part of, every urban development. Kilometers of piping network from collecting, distributing, supplying water from the source to the end user and final discharge. Can be surface water treatment plant or the oceans. But in the meantime, the urban population continues to grow exponentially, resulting in expansion of this built surface in cities and this water infrastructure network. But the paved surfaces in urban areas reduces stormwater infiltration, causing, on the one hand, more often overflow of the sewer system during these intense or peak rainfall events. But on the other hand, if rainwater doesn't reach the ground, or our groundwater table continues to drop. And all this causing a lot of negative impact to the planet, to the people, and to our economies, such as water damage, health problems, contamination of the oceans, as we heard, but also a freshwater shortage. So it is obvious by now that our cities haven't been built to cope with this, with climate change and all these impacts, but also this centralized model is not suitable anymore. So, but what can we do about it? Next, please. We have a solution. At Field Factors, we have developed Blue Blocks. It is a circular and nature-based system powered by rain. With Blue Blocks, we collect, treat, and store water for reuse in urban areas. So how does it work? We collect water locally where it falls, stormwater runoff, from paved surfaces. It can be roofs or pavement. We treat it with a biological filter to ensure it achieves the right quality, and we eliminate all contaminants or pollutants. And then we store this water in the underground, deep in the underground, in the natural aquifers, from where it can be recovered for reuse in the dry periods. So in this way, we create a local source for irrigation of sporting pitches or children to play in summer days, or for irrigation of urban green. But we also save the use of drinking water for non-potable uses. Next. Next slide. Yes. So what are the benefits? BlueBlocks is a compact and a reliable natural-based system. It improves the spatial quality by adding green and enhancing biodiversity. And of course, it also fits beautifully wherever it is installed. It has been designed to improve the urban space. So in short, we offer municipalities and project developers one compact system to tackle multiple climate-related challenges. Unique about BlueBlocks, it is that it's the first system in the world enabling circular water management in urban areas at this scale. So, and the system can be implemented at building, property, or neighborhood scale, adding green to the existing infrastructure or retrofitting projects with a minimum use of the space. Next. But the most important, it works. In 2018, we implemented the first pilot in the city of Rotterdam to solve pluvial flooding in the neighborhood called the Spanian in Rotterdam, and creating a local source of water for the irrigation of the sporting pitches of the Sparta Stadium, saving 50 million liters of water per year. Currently, we are working with municipalities, utilities, water authorities, and end users to launch new pilots in Rotterdam, The Hague, and Pijnack and Ouddorp in the Netherlands, but also in Madrid and Valladolid in Spain. To unlock deployment and scale our technology, we have identified the need to support municipalities with operation and monitoring our systems to secure, of course, especially water quality, but to gain trust, right, in that it works on the performance. With the Urban Water Challenge funding, we want to develop an H2Q service to operate and monitor our systems remotely. Next. By 2025, we aim to have 20 circular water systems in operation in 3 European cities, supplying 300 million liters of water per year. And we will be your go-to partner to implement climate adaptation solutions for freshwater supply in cities. In this way, actually, the real impact we will have is with BlueBlocks, we want to catalyze the transition towards a natural urban water cycle and help coastal cities to build resilience, climate resilience, by preventing flooding due to extreme rainfall, by enhancing livability, adding green and improving the urban space, but of course by ensuring freshwater availability for the future generations. Next. This is the ambitious team making all this happen. Thank you. Next. Well, was my last
Wonderful.
slide.
Thank you so much. So Swedish Fish, do you have any questions for Karina?
Karina, that was awesome. And I'm like, I'm not the best at being a mean shark, so I'm just going to be a friendly shark. Can you walk us through just a little bit more about how your solution helps cities build climate resilience? You talked a little bit about it, but maybe you could just flesh that out for us a bit more.
Yes, of course, as I elaborated, you have been elaborating on that as well, as in our cities haven't been designed to cope with extreme events, not with too much water, but also to litter. So what we do, we collect rain locally, we capture rain where it falls. So in that way we prevent flooding because we avoid water coming into the municipal sewer. So that's a way, one part of the climate resilience, but on the other hand, we create a new local source for fresh water supply. So we make water available in the dry periods. So that's, but of course, and something, a sort of a side effect, positive effect as well, that I like to mention personally, is that we are all talking about making green cities or greening our cities, but we also need water to keep that green, right? So in that way, that's also a way to help cities build climate resilience.
This is a really important solution, so thank you so much for sharing. If I put my oceans hat back on, can you help me better understand how blue blocks contribute to healthier oceans or mitigate ocean contamination caused by sewer overflow? Oh yeah, sorry.
Yeah, that's an important question. Actually, the core innovation of our technology, I mean, using aquifers to store water has been implemented in the Netherlands since the 70s, especially in the greenhouses, not in urban areas. So the core innovation is a biofiltration technology, which has been that we develop in my team, focused on treating all sort of pollutant loads that you can find in urban areas. That's the tricky part of having a decentralized system. When we put it in a square space in Rotterdam or somewhere else in Sweden or in another neighborhood, of course, depending on the use around, we will find different contaminants. So what we do is treating water locally, preventing contaminants to come not only in the underground, but also in the sewer, because we avoid water coming into the sewer system. So in the long run, that's what we believe a way to contribute to healthy oceans, but also healthy water systems in general.
Great. Well, thank you so much, Karina. From The Hague to San Francisco, I am now excited to have Aaron Tartakovsky join us from Epic Cleantec. Aaron, go ahead and take it away.
And once again, you've nailed my last name. So good work. Thank you. Let's see. Here we go. Great. So my name is Aaron Tartakovsky. I'm the co-founder and CEO of Epic Cleantec. So we say we are redefining urban wastewater. And what does that mean? Is that we are decentralizing wastewater treatment and reuse into individual buildings or groups of buildings. And one thing that we do that's special is that we produce both clean treated water that we can recycle back into the buildings, as well as a high quality soil product that we can use in and around cities. And because this, when we were invited to participate, I was explicitly told to have fun with this one. So I'm going to tell a little bit about our background story that we don't often tell. Here we go. So on the left there is Polly the Pug, who is effectively the original co-founder of Epic Cleantec. And as the story goes, my co-founder was walking down the streets of Tel Aviv when his dog did his business on the sidewalk, as dogs do. He was on the phone, not paying attention, didn't clean up after the dog. A police officer came driving by, sees this, writes him up a fine. Him being the fiery tempered Israeli entrepreneur that he is, rather than paying the fine and moving on with his life, decided that he was going to invent a new solution to deal with dog waste. To make a long story short, this innovation, which was essentially a high-tech pooper scooper device, got the attention of the internet, as all things scatological do. And they were approached by the Bill and Melinda Gates Foundation, who I think many of the folks on the call and the panelists will be familiar with the Reinvent the Toilet Challenge. The basic premise, which again touches on a lot of the things we've heard today, is how do we rethink wastewater infrastructure, water and wastewater infrastructure, not relying on just a centralized model that has essentially dominated how we've done things for about 200 years, but think about new above ground solutions that we can deploy more quickly, many times less expensively. And that's what we've done at Epic Cleantec. So at Epic, we've taken the basic principles of the Gates Foundation and scaled it up into buildings. Now, before I get into that, some of the issues that we're dealing with, and again, the benefit of going after everyone is that we've talked about a lot of these things. And actually, I wrote down a few of the quotes from Allegra: acute shocks to the system, continued stresses. Michelle, you said the status quo just isn't working. These images reflect that. So in the left, I wanted to illustrate urban density, where we have 70% of the world's population expected to live in cities by 2050. The approach we're taking just simply isn't working. So these pipes you're seeing here, this is the state of our infrastructure under our streets. And to take it to San Francisco as an example, we have 1,000 miles of sewer pipeline under our streets, 300 miles of which was built 100 years ago. And we're repairing it at a rate of 10 to 15 miles a year. Take that, multiply it by pretty much any coastal city, and that's the situation that we're dealing with. So we need to rethink just relying on the central underground infrastructure approach. So what we've done, as I mentioned, is created a new solution geared specifically towards buildings. So one of the things that makes us different is our team was actually born out of a building engineering firm. So we're fundamentally not water people originally. We are now, but we are not taking wastewater treatment principles and trying to squeeze them into a building. What we've done is designed a system specifically designed for buildings, which means it's smaller footprint, can fit into a 9-foot basement. We're dealing with lower flows. We're not dealing with millions of gallons a day. We're dealing with 5 to 150,000 gallons a day. So the system was designed to be more energy efficient and uses less chemicals. So this is actually the schematics of what a system would look like. We would go into the basement of a large building, or again, we can do it at a district scale for multiple buildings. We're collecting all the black water. The first step is we actually remove all of the solids out of the water. That's not only the wastewater solids, but everything else people shouldn't be flushing down into their toilets, including wet wipes, including feminine products, including condoms and everything else that we know we shouldn't be putting, but we deal with. Now that the solids are removed, we can much more easily treat that water and put it back into the building for non-potable applications to start. Potable down the road, but for now we're focused on non-drinking uses like irrigation, like cooling towers, like flushing toilets, which in many cases can replace up to about 90% of the potable water needs in these buildings. What you're seeing here is actually our first deployment in downtown San Francisco. This is the NEMA building, 754 units nestled between the Twitter and Uber headquarters. So we're right in the heart of all of it. This was our first successful deployment. This is actually what we do with the solids that we take out of the water. We turn it into high quality soil products. And what you're seeing here actually on the top left is two of my partners at Epic Cleantec. We're actually touring Gensler. Gensler is one of the largest architecture and design firms in the world. And we're doing that because we want to partner with the leaders in the real estate world to make this a thing, to help them get over the yuck factor and realize that there is no such thing as wastewater, there is only wasted water. And what we do is we show people very tangibly what we can do with these products. And that bottom right photo, that's our golden toilet. And that rainbow was not put in by me. That just happened because what we're producing really is repurposing gold in some cases. So our current momentum, we finished 18 months testing at Stanford. We deployed into our first building, as I mentioned. We just a few months ago closed our first initial seed round. We actually have, and I need to update the slide because we have 6 additional high-rise projects going up in California right now. These are typically large projects where we're going to be helping to not only reuse millions of gallons of water every single year, but those are millions of gallons of wastewater not being discharged into our central systems. So especially during those high flow events that you mentioned, Allegra, where we have storm water overflowing our systems, that's water, solids, nutrients that we're capturing within the building before they enter into the municipal sewer. And so what we're looking to do now is to get into more buildings, not only in San Francisco and California, but frankly, around the country and eventually globally. And one of the things we've done is worked on the regulatory front to make this a thing. So in San Francisco, we actually passed an ordinance in 2016 that requires that all new large buildings have to do on-site wastewater recycling. Similarly, in California, we have similar legislation that's basically leveling the regulatory framework to allow more buildings to be doing this. And I know that I'm coming up on my time, so I'm going to end there and transition to some questions.
Well, thank you, Aaron. I love that you're taking the waste out of wastewater and what you call repurposing gold. Every year, an estimated 70 trillion gallons of untreated wastewater is discharged into our oceans and rivers. How will EPIC approach this problem? And I know you just talked about it lightly, but would love if you could go into a bit more detail.
Yeah, so what we see ourselves doing for the water wastewater world, what distributed energy did for the energy world. So one building won't make a difference, but if we have 50 or 100 deployments in a city, especially a new city that's being built, that is millions and millions of gallons times multiplied by every building of wastewater that's no longer entering into our sewers. And what that does is it not only helps our cities and our municipalities to diversify their water supply portfolio, but it also helps them to deal with the stresses of wastewater load. We have more people moving into city. These facilities, which you mentioned, Michelle, were designed anywhere from 30 to 100 years ago, were designed for certain flows. So when we can come in, we not only are helping to repurpose this wastewater, but we're actually taking a lot of the strain off the utilities and therefore allowing them to not have to discharge untreated wastewater into our waterways and into our oceans.
That's awesome. Thanks, Aaron. And I love the origin story of EPIC. And I think the elaborate like pooper scooper idea could still be something that the world needs. But I wondered, with climate change, you know, coastal cities are increasingly becoming impacted by rising oceans and sea level rise. So how will the EPIC approach allow cities to become more resilient in the face of sea level rise?
Yeah, so the way our cities are designed now, especially with the reliance on centralized infrastructure, we put in pipes, and then essentially that's what we have. It's hard to move those pipes. It's hard to redesign cities, but what we've done is designed a modular approach, an above ground approach that's in these cities that's typically connected to a generator should power fail, for example. And what that allows us to do is we're not relying on pipes that are underground and are going to be the most quickly and immediately subject to ocean rise. But instead, we can design these systems to be protected by rising waters, just like any other building would. And as I said, they're modular. And we've designed this system to be able to fit into a door of a building, which means should we ever need to relocate systems, we can do that. And we have all the safeguards and the safety mechanisms built into these systems. So should there ever be a shock to the system, we're built and designed to be able to handle it.
Great. Thank you so much, Aaron, for coming today. Now we're going to be moving from San Francisco to New York. We now have Bessie Schwartz and Rohini Sengupta with Cloud to Street. Bessie, go ahead and take it away.
Excellent. Let's see how the advancing slides goes. Is it working for me? Oh, I have done it. Okay. Thank you. And exciting, always exciting to go last. I'm the co-founder and CEO of Cloud to Street. And we're the remote flood mapping and disaster risk management system, all done globally and without any field equipment. The majority of losses from disasters today is from flooding, and that is going up exponentially, driven mostly by coastal cities because of both climate change and population migration into cities around the edges of the ocean. The only way to survive without much more human loss and economic loss is to start with effective resilience, and that starts with sufficient information. Our mission at Cloud to Street is to make sure that all communities and cities have the information they need to preventively respond and prepare and respond more effectively and faster in the face of disasters. Founded originally with seed funding from Google, we have been used in almost 20 cities around the world by governments and aid agencies. And now we're taking our proven technology to insurance through a global partnership with Willis Towers Watson, which is the third largest insurance broker in the world. And with them, we're reinventing a new form of flood insurance that will work for everyone to build a financial safety net where we need it most. Let us see how next slide, Kelly. There we go. So how do we do it? What's going on in this technology? So Cloud to Street has a proprietary system that automatically ingests public and private satellites that are circling the Earth every day in order to monitor floods in near real time on the ground. And then we look back in time with those same satellites to understand through observations, not models, where flood risk is long-term and where it's emerging right before it happens. And we turn this into an easy-to-use dashboard for governments and the public in order to see their risk across time, but then importantly, to add their own questions directly into their system or add their own observations about where floods are happening or risk is happening. And together we're building a collaborative system to understand risk and floods in a new way. Next slide, if I can do it or Kelly can do it. And these systems are used to increase resilience throughout the entire disaster cycle. I grew up in New York City, and I remember firsthand when Hurricane Sandy hit, 10,000 homes were left off of the flood map because of insufficient information. The flood maps were 30 years old when Hurricane Sandy hit. And many of those homes, many of my neighbors didn't have the insurance or the protection that they needed. And we see this all over the world. Our has this to identify communities at risk and literally relocate thousands of vulnerable people. They've used this in order to pinpoint farms that haven't been able to recover after a flood and target aid to those that need it most to get the economy re-going again. And this system is critical for coastal resilience too, in unique ways that are specific to cities in those locations, like identifying wetlands that can be good protections against floods that are emerging. But one solution we haven't seen in the years that we've been providing our systems to governments and aid agencies, and that's the access to the capital that cities and individuals need after a shock. Next slide. Today, 70% of economic losses from floods globally are uninsured. And this number is as high as 99% in Africa, where major metropolises are booming around the coasts. And yet we know that by access to this kind of capital, having an insurance market where you are is one of the biggest driving factors in whether or not you and your community are going to bounce back after that disaster. So why, with this great solution and an eagerness by insurers to offer new products, is this not happening? And the reason mostly lies in the way that we analyze floods now. In short, it relies on a lot of ground equipment and manual work, which makes it slow and expensive, hence the gaps like those in my community in New York. So Cloud to Street reinvented a way of understanding floods and flood risk, all through satellites and community intelligence. Next slide, Kelly. And this enables us to, let's see if we can go, to do it in a much more affordable, a much more faster, and a completely remote way of analyzing risk and mapping floods. And this can revolutionize insurance in two different ways. The first is by analyzing risk, we can enable insurers to see new opportunities in insurable assets and to price premiums affordably to new places. This is good. And then the second way is that by mapping a flood and what's been impacted in near real time, like in this hardware factory in Thailand or this small shop in Chennai, India, we can replace the field appraisers and actually get the capital into the hands of those who need it most automatically, transparency, and very quickly. So we are working with insurers around the world, starting with Willis, in order to create new forms of insurance based on this technology. And we are so excited to be collaborating with the Urban Water Challenge in order to do our first pilots with insurers in the US and South Africa. So in short, Cloud to Street, our systems have already revolutionized disaster resilience for governments in over 20 countries. They've used it to identify 2 million vulnerable people. And now we're turning to use the same technology for a critical part of disaster and coastal resilience, and that's in parametric flood insurance. So we hope you'll join us, and thank you so much.
Awesome, thanks, Bessie. This is such a neat idea of, bringing together insurance and flood mapping to make it much more efficient. I just wondered, are there any unique challenges for flood detection in urban environments?
Yeah, so we're very focused. It's a great question. We're very focused on urban areas because that's where the majority of the assets are, the majority of the vulnerability is. And from a need perspective and from an insurance perspective, there's no unique barriers. In fact, there's unique advantages because of the distribution pipeline and because of the opportunity. But there's really unique technology challenges when it comes to detecting floods from the sky. And that's mostly in the resolution of the floods in cities. They move very fast through city streets and it's just much smaller. So we're often having to use 30-centimeter radar satellites and optical satellites in order to look down and detect floods in real time. So while it's a huge opportunity and in many ways much easier to reinvent flood insurance in cities, it's much harder technically.
Thank you. This is a really important global problem, and you've created a global and accessible solution. So thank you for sharing. I was wondering, how would the insurance product actually build resiliency for the city, for people, and ultimately for the ocean?
Yeah, that's an excellent question. And for that, I'm actually going to turn it over to my colleague, Rohini, who leads our insurance work as a former broker herself.
Thanks, Bessie. Thanks, Allegra, for that question. It's a very good question, and I think it's important to think of insurance and risk management and risk transfer in general, operating on multiple scales of an economy, of a society. So from the people perspective, from the household perspective, there's tons of literature about how insurance helps people recover faster from shocks, which then helps them kind of create resilience to future shocks by thinking about their risk, quantifying their risk, paying for their risk, or at least trying to think of a way to finance the risks. It's the same thing for cities and governments. We've seen more and more governments look for risk transfer solutions in order to kind of pre-finance some of their risks and kind of build resilience by thinking about where the money comes from when there is a disaster. And then for ocean health and for ecosystem health, as Bessie said, we've done work on how flooding impacts marine habitats, coastal wetlands, and other types of ecosystems. And you can also think about the risks of flooding to these ecosystems and think about how, if you can get additional adaptation funds through insurance, you can start to free up some other public sector adaptation funds, government budgets to kind of do more ocean conservation work or whatever else is helpful. And then of course, also when you have more money for these adaptation purposes through insurance, you can better kind of plan for and mitigate for those things like sewage water backup and kind of like stormwater flooding that affects ocean ecosystems. So yeah, that's in a short answer. That's how we think about it on various levels.
Great. Well, thank you so much, Bessie, Rohini, Aaron, and Karina, and thank you, Swedish Fish, aka Michelle and Allegra. Now, audience, it is up to you to decide who survived this very, very scary Swedish fish tank. Since we have run out of time, we will be releasing the poll via email as a follow-up to the session. And know that all the votes matter. Through a variety of sessions, we'll be tallying votes of a public choice award who will win an additional $5,000 in deployment funding. So please put your vote out there. Again, thank you so much for joining the Swedish Fish Tank, and please follow along these Urban Water Challenge finalist journeys with Imagine H2O. Thank you again. Bye now.